guys. So last week we finished our part of Module 5 on space systems and Earth formation. We're going to be starting on the Big Bang this week. So we're going to start off just kind of talking about where the name came from and just kind of background information on that. And then you'll have a short little assignment to do in here. But we will be in this module here, 5B. So when you get to the home page, you just scroll down and click on that, and that'll take you to where we are. So, Big Bang Theory. Again, we talked about what a theory was previously before we left, and we'll go over that again towards the end. So, this is kind of an interesting story, how the name came about and how the idea came about. We have this guy, George Lemaitre. He's our main character in here. He was a Belgian Roman Catholic priest, mathematician, astronomer, professor, super smart guy, and he proposed an idea that the universe is expanding, which was completely different than what other astronomers were thinking at the time. So his idea was that there was a very small point. He called it like the primeval atom, or the cosmic egg was another name given for it. But he thought that the universe began at a very small point and began expanding, and is still currently expanding. Albert Einstein was not in support of the theory. He thought it didn't make sense. George just was hoping that people would listen to him. He was laughed at. His idea was thought to be absolutely ridiculous. Many astronomers at the time thought that they had the hypothesis, the idea that the universe was in a steady state. Einstein even told him, "Your calculations are good." He was a mathematician. "Your calculations are correct, but your physics is atrocious." So coming from Einstein, I guess that it's kind of a big dig. So two differences between the Big Bang model and the steady state model. So the Big Bang model shows that the universe expands and the density of galaxies lessens, and that makes sense. As your space gets bigger and bigger, galaxies aren't so concentrated together. The steady state model, what they had thought before Lemaitre, was that as space gets bigger, more galaxies form. So we have a constant amount of galaxies, or a constant increase of galaxies, a constant density of galaxies in the universe. So the steady state model was what they thought. Eventually we'll get that debunked. This guy, Fred Hoyle, he thought it was so ridiculous that he referred to it as the Big Bang. So the name of Big Bang wasn't something that the guy that came up with it came up with. This was somebody poking fun at him. As the science was confirmed, though, as they figured out that Lemaitre was correct and more scientists added on more evidence for the Big Bang, the name stuck. So it started as a big joke. They were making fun of him, and in hindsight, that was the name that stuck. Initially, Einstein had told Lemaitre that his ideas didn't work. Lemaitre took that as a challenge, which a lot of scientists do. They don't like being rebuffed by other scientists. They want to be the smartest people in the room. So he took the time and he showed Einstein, like, no, my ideas actually match up with all of yours, the stuff that you have already discovered. My ideas back what you're coming up with. I'm just looking at it in a little bit different way. And Lemaitre was saying, my idea is right, that the universe is expanding, and the galaxies are getting further apart, and your idea of a steady state is wrong, and your work already shows me that I'm right. So later on, Lemaitre presented his ideas again, and he took more time to make the physics a little more accurate. Um, After this, Einstein, very different quote from what Einstein had previously said. After listening to this, Einstein told him, "This is the most beautiful and satisfactory explanation of the universe to which I have ever listened." So Lemaitre was able to show how his ideas actually worked with what Einstein had already discovered, and showed that Einstein was incorrect on his steady state model, that the universe is actually expanding. So this is not obviously a direct quote from Einstein, but this is how hopefully most scientists would approach their work. Uh, that it's not bad to be wrong. That's how science works. People are incorrect, and then we test those ideas and we find an actual cause, an actual reason. We find facts behind it. So Einstein was probably not too worried about being wrong. He's a scientist, and he just wanted things to actually be correct, and that's what science is trying to do. Um, so, thanks to all of Lemaitre's amazing work, we derived a law of physics. That law said that the observation that galaxies are moving away from the Earth at velocities proportional to their distance. If we want to break that down into a little bit easier terms, the further something is away from Earth, the faster it is moving, because it's expanding at a proportional to the distance. So you would think that with all the stuff that Lemaitre did, um, that they would name a law after him. Nope, that's not how it happened. So they in fact named this law Hubble's law. Sometimes you'll see it hyphenated as Hubble-Lemaitre's law, but typically in most textbooks on the internet, you're going to see it referred to as Hubble's law. So Hubble was not the first guy. We had Lemaitre, who was French, so that might have had something to do with it. But he was the first one to derive the calculations for it, um, but he didn't really get the credit for it. So we have continued to improve on Lemaitre's Big Bang theory. Lots of scientists, lots of cosmologists have worked on it to verify its accuracy, and we just continue to see that it is very it's a it's a good theory. It has lots of facts behind it, tons of evidence. I have listed 6 pieces of evidence over here on the side, which we'll look at later on. So universal expansion, Hubble's law, that was kind of the groundwork that Lemaitre put down. Then the second one, 3 degrees background radiation. We'll talk about that one later, but that one was a huge breakthrough. I think around in the 60s, and that's when a lot of astronomers, cosmologists, other scientists said this Big Bang, this all this works. The evidence, this 3 degree background radiation, this is a huge piece of evidence. This is the smoking gun. This tells us that this is definitely uh, a correct idea on how the universe started. Um, so earlier in the year, we had talked about what the word theory means, and we talked about that most people don't understand what the word theory means. You'll be answering that question on the assignment later on, and we'll watch this video later. I'm not gonna start this video right now. I took this from a big article. I just took out the few paragraphs that I thought were relevant, so I'll go through them and we'll talk about them. So Wendy Friedman, who is a veteran cosmologist at the University of Chicago, said that one key point is that the Big Bang was not an explosion of the kind any person has ever witnessed. The first thing to get rid of is an image that looks like a bomb going off. That's not what was happening with the Big Bang. Um, that's what people think of when they hear the word, but that's not what happens. The Big Bang is an explosion of space, not into space. There's no center or edge to the explosion. There was no place outside of the Big Bang, so it was not expanding into anything. Rather, all of space began expanding everywhere. This is why galaxies appear to be moving away from us in every direction. Any observer, anywhere, would see the same thing. I sometimes think the Big Bang is a metaphor for human psychology. In a sense, you can think of yourself as the center of the universe, since that's how it looks to all observers. But in a deeper sense, nobody is at the center, since the expansion is everywhere and all of us are in the same situation. For anyone wondering how the universe could have formed from an explosion at one point in space, the answer is that it couldn't. The idea truly is wrong, but it is also not at all what the Big Bang describes. Which brings me to the other key point. The Big Bang is a description of how the universe began, not an explanation of why it began. It does not assume anything about what made the universe, and it does not assume anything about what, if anything, came before. So the Big Bang was not an explosion. It is just how the universe began. We see how we can look back in time and go back to almost to the very point where the Big Bang happened, where we have that singularity. We don't know why it happened. We don't know if there was anything before it. That's nothing that the Big Bang theory can tell us. It can just tell us what happened. It tells us how it happened. It doesn't give us any reason for why. That is a different question completely. So one way that I like to think of it is this video that we have here. So we have this hamburger being pumped up. We can kind of think about the Big Bang, the expanding universe as this hamburger. Initially, all we have is a bun. The bun is pretty basic. It is just hydrogen and helium. There's nothing super interesting about it. Big, fluffy, nothing much to it. As the universe, as the hamburger expands, we have different areas, different areas that might be meatier, different areas that might be a little less meaty, and we have places where galaxies start forming. Lots and lots and lots of galaxies and stars and planets and things like that. So this just keeps getting bigger and bigger. It is not expanding into anything. The hamburger is just getting bigger, and that's similar to what's going on with the universe. Our universe is still expanding. Will it ever stop? Don't know. That's something that we can talk about another day. All right. So your assignment. We go over here into module 5B. You will be working on this Big Bang introduction. There's a short little thing for you to read and a few questions that you answer, and that'll be due a week from Tuesday. All right, talk to you guys later.